Good morning, my dear friends. See now, we'll go to the another problem in the elastic shortening. Okay, I will read the problem now. A straight pre-tensioned concrete member, 12-meter long, with a cross section of 400 mm by 500 mm. Okay, is post-tensioned by four tendons of 250 mm square each. In a sense, there are four cables. There are four cables in that beam. Each cable is having a cross section of 250 mm square. Okay, the tendons are tensioned one after another. This is very very important now. Okay, all the four cables are not tensioned simultaneously here now. Okay, all the four tendons are tensioned one after the another. Okay, to the stress of 1000 newton per mm square. In a sense, each tendon is stressed to a level of 1000 newton per mm square. Okay, take m is equal to 6. Directly he has given the value of m as 6. Okay, m is equal to 6. Compute the loss of pre-stress due to elastic shortening of concrete. Okay, so he has asked you to find out the elastic shortening loss. How can the loss be counteracted? So if at all you want to counteract this loss, how do you do it? Okay, so now we'll start with the solution now. Okay, AC, area of concrete, can be now easily calculated. It is 400 mm by 500 mm. It is so much. But now in this problem, in the problem he has nowhere he has stated what about the eccentricity. Okay, nowhere he has said how the cable, at what level the cables are placed. Okay, so I can assume that, okay, since he has not given the eccentricity, I can assume that the tendons are placed concentric. In a sense, wherever the C is there, at that level only the cables are placed. So since I am assuming that the tendons are placed concentrically, E can be taken to be equal to 0. Eccentricity is 0 now. Okay, so now I want to calculate the stress in concrete at the level of CGS. Okay, in the sense, eccentricity is 0 now. So you can easily calculate the FC value as P by AC, stress in concrete, P by AC. Baba, P value is 1000 Newton per mm square is your FS, stress in steel, into area of steel. Okay, area of steel is 250. Okay, so Fs into As will give me the pre-stressing force. Okay, divided by AC value, I know it is 1.25 Newton per mm square. Okay, so this is the value of Fc. In a sense, it is the stress in concrete at the level of CGS. Okay, so now what happens is, but now there are four cables, as the problem says. All the four cables are not stretched simultaneously. They are tensioned one after another. Okay. So as I have already talked, okay, sir, now the first cable, okay, the first cable when it is tensioned, Baba, it will not undergo any loss of pre-stress due to elastic shortening. Okay. But the first tendon will undergo the loss when the other three cables are tensioned. Okay, when other three cables are tensioned, the first cable will undergo the loss. So now the first tendon will undergo loss three times. Okay, it is three times MFC. Understood or not now? The first cable will undergo the loss three times because other three cables are stretched after this first cable. Am I right now? So now the loss is here now three times MFC. So 3, M is 6, FC is, you know, okay, it is so much. Next, if at all I want to calculate the loss of pre-stress in the second tendon, okay, sir, now it is 2 times MFC because after this stretching, okay, third and fourth cables are going to be stretched. Okay, so it will undergo 2 times the loss. Okay, so it is 2 m value I know, fc value I know, it is so much, 15 Newton per m square. Okay, this is the loss in the second cable, and in the third cable it will undergo the loss only one time. Okay, because the fourth cable is stretched. Okay, after this third cable, so it is 1 times MFC. So 1 M value I know, FC value I know. Okay, it is 7.5 Newton per mm square. This is the loss in the third cable. Okay, and in the fourth cable doesn't undergo any loss. Okay, so in the fourth cable the loss is 0. Okay, so now I want to calculate the average loss of pre-stress. Okay, average loss of pre-stress I would like to calculate. Baba, this is the loss in the first tendon, this is the loss in the second tendon, this is the loss in the third tendon, 0 is the loss in the fourth tendon. Okay, all these divided by 4 because I want to calculate the average loss. Okay, so average loss is 11.25 Newton per mm square. Okay, so now usually what happens is now this average loss of pre-stress will be usually equal to half of the loss in the first tendon. Okay, loss of pre-stress in the first tendon is how much now? 22.5. Okay, so it's half of loss of pre-stress in the first tendon. First tendon loss is 22.5. So half into 22.5 will give me again the same value, 11.25. So usually it will be, this average loss will be equal to half of the loss in the first tendon. Okay, so now this is one thing. But now another important thing what he has asked is how you can counteract the losses. Okay, so but now how I can counteract is, say take for example, if I take the first tendon, the loss is 22.5. But now what I do is now 1000 Newton per mm square is the applied pre-stress. Now this plus the loss. So now if I apply 22.5 Newton per mm square as the stress in the first tendon, okay, it will not undergo any loss. In a sense, I mean to say that it can be contracted, okay, by applying this much pre-stress. Similarly, in the second tendon, if I apply 1000 plus 15, because 15 is the loss, okay, 1000 plus 15, 1015 Newton per mm square, if I apply the pre-stress, okay, then the loss can be contracted. Similarly, in the third one, okay, 1000 plus the loss, so much. And in the last cable, fourth cable, 1000 plus 0 is the loss. So only apply 1000 Newton per mm square. Okay, this is how you can counteract the loss. Otherwise, on an average, what you can apply is in each tendon you can apply 1000 plus the average, this thing now, average loss of pre-stress you have found it as now 11.25. Okay, 1000 plus 11.25. So it is 1011.25 Newton per mm square. Baba, if you apply this much pre-stress in all the cables, in all the 4 cables, then also it can be contracted. This is another way of counteracting the losses. Okay, thank you very much.